Everyone, in this video we are going to be talking about stoichiometry. So the big thing with stoichiometry is that we are going to be doing conversions, and so the first thing that you need to do is pause this video and write this chart down, or this map. This map is going to show you exactly where to go depending on what you're given and what you need to go to. Couple of things on this. Make sure that you remember that MM equals molar mass. Okay. And then your given could also be called your A, and your need could also be called your B. But you want to pause and write this map down. So I trust that you have paused and written this map down. Then we have, well, what is stoichiometry? So you want to, again, write this definition down. But stoichiometry is the study of quantitative relationships between amounts of reactants and products in a balanced chemical reaction. And you want to remember that quantitative just means that you are dealing with numbers. So basically, we're looking at the number of reactants compared to the number of products. And what we're going to be doing is we are going to be converting. So we're going to convert from, maybe grams of one thing all the way over to grams of another thing. And so that's where the quantitative relationship part comes in, is the fact that we are using numbers for this. And then the next thing that we need to talk about is something called STP, which is your standard temperature and pressure. So these are kind of, in our chemistry world, these are going to be our standard. So anytime we're talking about temperature, it's going to be 273 K, which is Kelvin. Pressure is 1 atmosphere, which is ATM. And then volume is going to be 22.4 liters. We are going to be using the 22.4 liters. In our conversions, but you need to be aware of STP and what it stands for, as well as what it is. Okay, now we're going to do some examples. So we're going to start out with example 1. So our first example says, determine the mass. So determine the mass of lithium hydroxide produced when 0.38 grams of lithium nitride reacts with water. And then our equation for this is going to be Li3N plus 3H2O gives us NH3 plus 3 LiOH. Now, the first thing that we need to do is we need to figure out the type of reaction. And if I look at this one, I'm going to see that the N comes over here with an O and an H. Then this H comes over with the N. So my type would then be double replacement, and you can abbreviate that. My balanced coefficients, or if you want to just say BC, that's fine, are going to be 1, 3, 1, and 3. Okay, and then we're going to use our guess method. So we're going to start out with our G, which is our given. And if I come up here, I'm given 38 grams of lithium nitride. Now I have to think back, well, what is lithium nitride? I know I'm going to have Li and I'm going to have N. So it would be this. Or if you're like, I can't remember that, it tells you it reacts with water. So that means it has to be the other reactant. So we are given 0.38 grams of Li3N. Then our unknown, the thing that we are trying to get to, is mass of lithium hydroxide. And if you remember, our mass is going to be in grams. So grams of lithium hydroxide. So now we have to figure out our unit path. And if you remember, we always start with what we're given. So we're given the Li3N, and that is 0.38 grams. After that, I come back up here to my chart, and I see that if I start with grams, I follow my arrow, and I'm going to go to moles. So we're going to go to moles of given, which is going to be Li3N. And if I go back, the way that we do that is we divide by our molar mass. So, okay, and then after moles of LiN3, I have to go to the moles of need. So that's going to be moles of LiOH. And then finally, I'm trying to get to grams, and that is where I'm going to go next. Grams. And so here, let me write divide under the bottom of my arrow, will be our mole ratio, and then here we'll multiply by the molar mass. Now, since I have to use the molar mass, that means that I have to find the molar mass. And I'm not going to go through and show you this on your periodic table. I trust that you can find your molar mass without me having to go through and show you on your periodic table. But I will show you how we work it out. So there's the Li3N, and then for LiOH, okay, so now we're ready to set this problem up. So I always start with what I'm given, which is the 0.38 grams of Li3N. Well, if I'm given grams of Li3N, that has to go on the bottom. The thing I'm trying to get to, which is moles of Li3N, goes on the top. Then if moles of Li3N is on the top, moles of Li3N has to be on the bottom, and then moles of LiOH would go on the top, and then last, mole of LiOH, and then grams of LiOH. Okay, now here, whenever you see mole with a gram, or with liters, or atoms, particles, any of that stuff, your mole is always going to get a 1. Okay? And if you think back to molar mass, with molar mass, if I'm thinking of molar mass of Li3N, we're saying that 1 mole of lithium nitride is going to weigh, if we look back up here, 34.83 grams. That's why it gets the 1. The only time that you are going to have a number other than a 1 in front of the mole is when you see this, mole over mole, because you are finding the mole ratio. So you're going to have to go back to your equation and look at the coefficients that are in front of your LiOH, which is a 3. So that means we're going to come down here. We're going to have a 3 in front of the LiOH, and then in front of our Li3N would be a 1, because that is its coefficient. And then we have 1 mole, and then our 23.95 grams. Okay, and whenever you type this in your calculator, you want to type 0.38 times 3 times 23.95, and then divide all of that by your 34.83 and round to 2 decimal places. And whenever you do that, you should get 0.78 grams of LiOH. But again, I want to reiterate, the only time you will have a number that is something other than a 1 in front of the mole is whenever you are looking at the mole ratio. That is the only time that that will happen. Okay? So, let's look at another one. So, this is example 2. And this one is how many atoms of zinc chloride are produced from 26.5 grams of HCl. And so your equation is zinc plus HCl gives you zinc chloride plus H2. So we first got to look at this and see if we are balanced. Okay? We are not balanced. So in order to balance this one, I need to put a 2 in front of the HCl. I need to also tell the type. So if I look at this, zinc is by itself, hydrogen is by itself. Since I have a single element by itself on both sides of the equation, this one is going to be a single replacement. My coefficients are going to be 1, 2, 1, and 1. And then we start out with our guess method. So for this one, we're given the 26.5 grams of HCl. Then they tell us that our unknown, the thing that we need or we're trying to get to, is atoms of zinc chloride. Okay, so then we got to figure out our path. So how are we going to get there? Well, we're going to start with grams of HCl. We go back and we look at our chart. If I start with grams, again, I've then got to go to moles. So we're going to go to moles of HCl. From there, we got to go to our moles of need, which in this case, our moles of need are going to be zinc chloride. And then where this one is different from our last example is we're here at moles. We're now going over to atoms. So atoms of zinc chloride. So here we have to divide by our molar mass. We have our mole ratio. And then here, we're going to multiply by 6.02 times 10 raised to the 23rd. Okay? Now, we're going to have to find the molar mass of HCl. So HCl, we have 1, 1.01, 35.45. Grams per mole of HCl. So we're ready for our setup. So we start with what we're given, which is the 26.5 grams of HCl. If I start with grams on the top, grams has to be on the bottom, and then mole of HCl. Then we're going to have mole of HCl over mole of zinc chloride. Then mole of zinc chloride, and then atoms of zinc chloride. And then we fill in. And if you remember, the only time I have a number other than 1 in front of the mole is whenever I'm doing the mole ratio, and that is mole over mole. So here I have gram over mole, so 1 mole, and then my molar mass of 36.46. Here we have to look at our coefficients. So in front of the HCl, there's a 2. And then in front of the zinc chloride, there's nothing, so it's understood to be a 1. Then we have 1 mole is 6.02 times 10 raised to the 23rd atoms. Okay? And then we plug that into our calculator. And again, whenever you plug it in, you want to have 26.5 times 6.02 times 10 raised to the 23rd over 36.46 times 2. And whenever you do that and round to 2 decimal places, you should get 2.19 times 10 raised to the 23rd atoms of zinc chloride. And I do want to tell you that if you are going to atoms, you should have an exponent that is like 10 to the 23rd or 24th or something like that. It won't be in the 40s, but you should get a times 10 raised to the something in those, if you are going to atoms, particles, any of those types of things. Okay? And then we have our last example, which is going to be one that involves liters. We've not done anything with liters so far, so that's why I wanted to do this example. So this is example number 3, and it is how many liters of N2H4 gas at STP are needed to react with 386.70 grams of O2. Okay, and then I'm going to give you the equation for this one. So your equation is 5N2H4 plus 2O2. And again, that's an O2, that's not a 20. So 2O2, 4H2O, plus 3N2, plus 4NH3. Now, for the type for this one, we've not seen anything that has 3 products, but we're going to go that this is a double replacement. And the reason why is because we're going to have the fact that we're going to have some of the H's that go with the O, but then we also have some of the H's that go with the N, and then they break up. So we're going to go with this one as a double replacement. If you said that it was a single replacement, that would work as well, but double replacement. And then for the balanced, they've already given us the coefficients 5, 2, 4, 3, and 4. Okay? And then for our given, we start out and we are given this 386.70 grams of O2. Our unknown, we're trying to get to liters of N2H4. So then we've got to figure out how are we going to get there. So we know we always start with what we're given. And then I hope that you figured out by now that you're always going to go to mole of your given and then your mole of your need. And then from there, if I go back to my chart, so I went from my grams of given, moles of need. Now we're going to go to liters of need. which in this case is going to be liters into H4. So here we divide our mole ratio, and then here we multiply by 22.4. So then we have our setup. So I start with what I'm given, which is the 386, but before I do that, I have to find the molar mass of O2. So I have 2 times 16.00 is just going to be 32.00 grams per mole of O2. Now we can do our setup. So 386.70 grams of O2, grams of O2, mole of O2, mole of O2, mole of N2H4, mole into H4, and then liter of N2H4. And then again, if I see gram over mole, it has a 1, and then our mass. Here, this is going to be my mole ratio, where it's mole over mole. So I have to go, I have a 5 in front of N2H4, and then I have a 2 in front of O2. And then here, 1 mole is going to be 22.4 liters. So then we plug this into our calculator, and remember 386.70 times 5 times 22.4 divided by 32 times 2. And whenever you do that and you round to 2 decimal places, you should get 776.73 liters of N2H4. Okay? And that is it for stoichiometry.